about DB or anything, but how many of you actually interact with databases? Okay, so I hope you learned something new from this. So let me start with my experience a few years back. We were working on a product. The product was about designing goodies online. That is, you come to a website, you can design your goodies, like for example, take a t-shirt, you want to have certain images or certain text written on that, and then you can say this is a t-shirt size I want, and then you pay for that, this many t-shirts I want, and then you pay for that, and then the t-shirt gets delivered to you. It's not a new thing now, but when we were working, it was a new thing. And so it has to do a lot of things correctly. That is, the images, their colors, the position about different elements, right? The angle in which certain things are displayed. It has to be clearly converted into a PDF that we have to give to the printing vendors, and so that they can put it on the in the goodie, whatever it is, if it is t-shirt or a mug, then and deliver to you. So that conversion from the screen to the PDF has to be very accurate. Okay, and so in software, you know, change is the only constant, right? And what happened was we had a lot of supported, so we were doing continuous delivery. That is, we started with images first, then started supporting text, right? When we were working on certain text features, say transformation, gradient of the text, right, color gradients and stuff like that, when we realized that the current library that we are using for converting the what you see on the screen to a PDF, that didn't support the accuracy as we wanted. So certain transformations were not correct. Okay, and then we found that there is another library that has a better support for that. So we have two options. One is change the current the existing functionality that we have to the new library completely, or we can start with the new feature just with the new library, and then gradually move, because maintaining two different kinds of implementation for different for the same thing is not a good thing, because there will be a clash over a period of time. So what we took was something called as parallel change. So what we did was, we created in the code, we created an abstraction layer for this, and then we started with textual features which we wanted to release first, and then we use the new library, okay, and use the new implementation. The existing features that we had the it used the old library itself, and we did that through an abstraction. And what we did was, we slowly moved to the new abstraction layer and got rid of the old implementation completely. Okay, so that what we gained was feedback. That is, we were able to continually deliver, and while changing, we are sure we didn't want to get hit with another bottleneck. Like after a certain time, the new library also have another failure, right? Even in that case, we have a fallback, right? So this helped. This made this gave a lot of safety to us. Without affecting the functionality, we were able to gradually change. And considering that the product is about the design, and what we are changing is a major part of the system, this is very, very safe. Okay, and this is not a new concept that we introduced. This pattern is called branch by abstraction. Martin Fowler has written a very detailed post about how to use this concept. Okay, and what you do is, you have two kinds of implementation. This is where you have parallel implementation. So it can be for a change in the framework, it can be for a change in your database, okay, or it can be for anything. And then you implement two things together. You have parallel implementation. Over a period, you move from one to another and kill the old implementation. Okay. And what we are doing over here is mainly two things. One is fundamentally the refactoring. We are changing the implementation without affecting the functionality, right? So we are rewriting the existing feature to another implementation, but for the users there is no change. And then the beauty of refactoring is the small changes, right? I mean, we don't do a lot of code. We don't change, if you are actually doing refactoring, we don't change a lot of code at the same time. We take it in small steps, and then make sure that it works. That is when you actually see the power of refactoring. And after a certain 10-15 steps, you see, okay, major change. And so that is why it is a series of small behavior preserving transformation, because in the end you see a major change. Okay, and the next thing is continuous delivery itself, right? You can continue to deliver after every change, right? Without you don't have to wait, right? Every change can go into production if you want, right? And that is very, very, very powerful, because what you get is feedback, right? And as small changes are going in, if there is a problem, you know exactly what caused it, right? If a lot of changes are going in and something goes wrong, then you will be in a tense mode. Okay, what actually caused this, right? If only small changes are going, you know, oh, this is a change, I can just roll back. Okay, and with parallel implementation, you don't have to have a failure in the feature, because you already have the earlier implementation, right? So these two things combined together, using the technique branch by abstraction, we can make a big change to the application, architectural change to the application, without having the users having any need to know any. They don't feel at all the change, right? Without any degrading performance. Okay. And this lower the risk of releases, right? You know that anything can go wrong anytime, right? And that is, we have seen it again and again. Things will always go wrong, right? How can you lower that risk, right? It is not that there will not be any problem. That is what we are optimistic about, but it doesn't happen that way, right? If you have spent some time in the software industry, you know that things will always go wrong. What worked yesterday doesn't work today. Something has changed, right? So this is the power of continuous delivery, and you combine that with refactoring, you get a lot of value. Time changes. I moved on. I've started working with a product called Yoga Tree. This is a digital marketing product for yoga centers. Okay, so if any of you work with startups, the key over there is evolvability. You start with an idea. You think that is what the users want or the market wants. You go there, and then you realize that, okay, that is not what they want. Like how the ideas change, the code also has to support it, right? The major bottleneck that is database, especially have a lot of users in the system, right? How do you change your database depending upon the market changes, right? Can we have a low risk releases there too? Right? If any of you have dealt with a database, the worst thing that can happen for a product is a database going down, right? Backups not working, right? I know everyone would have had some kind of experience with that, right? So it is very slow and it is high risk, right? Because everything is in the database. If something happens to that, you are screwed up, right? How can you make it less risky? Can we apply similar techniques there? And that is where database refactoring comes into picture. Okay, so we can apply the similar refactoring techniques in small steps, giving you a major transformation to database too. Okay, so that helps you to continuously deliver. Even database changes can be delivered in small steps. Okay, so that in case there are issues, you can always roll back. Or you have parallel implementation. Okay, so let's look at some examples. I've been talking. Okay, so these are real examples that I had experienced. So it's not like I made up something for you. Okay, so these are actual changes that I've made while working on production database. Okay, and so in the application we have something called as customers can book a trial using the application with a yoga studio. Okay, so they can just attend a class even before becoming a member. So to experience, right? Yoga is not like so that they can make a decision whether to go there or not, and that's a kind of a selling for the yoga studios also. So we had a trial bookings table. We know which customer booked it, when was it booked, and the status. The status talks about whether they attended the trial or not. Okay, but that's not it. they also for the funnel to work, they also need to know whether after attending did they become a member, or they attended but didn't become a member. So many value can go into that status. Later we realized that this just one status field is making a lot of problem. We want to split it and make a lot of decisions. Okay, how many of them are attending but not converting, right? How many of them booked but didn't attend? For that, just one field is creating a lot of problems for us. We wanted to split that, and that is called a split column refactoring. So we want to split that particular status field into multiple, whether they have attended and whether they've become a member. Okay, so instead of just removing that field and adding two fields and migrating, what we did was we did a parallel implementation. We have the existing column, also created two new columns, migrated the data. So the thing is about rollback. In case something goes wrong, we already have the data in the old field. And while migrating, what you have to make sure is that anything that gets added to the old column gets added to the new column also. Okay, so either we can use your own MVC framework to do that, or you can use database triggers to do that. Okay, and then we change the application to reflect two new data, and we also made reports, or say even form updates. Like they can when they are updating the status, they can update to two different columns. Okay, and once we are sure that this works, and we completely migrated to the new one, just get rid of the old one. There is no data loss because we already have the migrated data. Okay, so this is the safest approach. So it goes through a process. It's not just one-time process, right? You start with the migration, write the triggers to save to the both the fields, and after a while, once you gain the confidence and the entire application is reflected on the new field, then you migrate to the new one. Okay, so this is one type of refactoring. Let's look at another refactoring, split table. In this case, we want to split one table into multiple. Okay, so in this example, so once they become member, they have billing cycles, like they take a package, right, 3 months package for X amount of time. Okay, so we had that reflected on the database, but after some time we realized that, okay, some studios, some yoga centers have the concept of partial payments. That is, they accept 50% initially, and after a month, especially if the package time is like 1 year or so, they can pay in multiple installments. So this will not suffice. We need to have a one-to-many relation like this. Okay, so here also we did the same thing. We created a new table, we migrated the data, but we retained the existing structure, okay, rather than deleting it at once. Okay, so when a payment is made, it saves to the both the tables. Okay, and we added the functionality for partial payment in the system. In the UI, we had a new page to do that, and then once we have migrated the entire code base, and this becomes very critical when you have a lot of dependencies, downstream dependencies. Say you are exposing APIs, right? At that case, you can't just delete an existing field like that. You need to make sure that the customers or your clients, right, the downstream dependencies what you have is completely migrated to the new implementation. Okay, so the duration of the transition period depends on how much dependency you have, right? Or your Android application or iOS applications, right? So we have to make sure that the applications are updated. Only then we can make these kind of changes. Okay, and in this way we are not losing that time, because we have the new implementation already. We are not waiting for that, right? So this is the same refactoring process. You have the old schema, then you have a transition period. Duration of the transition period depends on the team, the product, etc. And then you have the new schema. Okay, and this is what is called the expand contract pattern, similar to the branch by abstraction concept. This you can apply to databases. Okay, especially the schema changes. Okay, and the database refactoring book, there is a book called database refactoring. The examples that the refactoring that I explained are from that book. Okay, and it talks about a lot of different types of refactoring, how do you want to approach them. For many of them, the expand contract pattern applies, especially when you are changing the schemas, or say you have a table and then you want to change that to a view, or vice versa. You had a view and you want database view and you want to change that to a database table. In those cases, we can use this expand contract pattern very well. Okay, but it may not apply to every refactoring. Okay, so it's good. It's a good idea, but what you need to make sure that you are implementing this. Okay, so what are the basics that is required for you to get started with this, right? One is versioning, because every database change has to be versioned, like your code, right? Git gives you a version, right? At a time, if you want, you can always go back to a specific version of the code, right? Similar to that, every database script has to be versioned. Okay, most of the, as far as I know, most of the MVC frameworks or ORM frameworks comes with a database migration tool along with that, or Liquibase is one which I've heard very popular in the Java world. So I usually work with Ruby on Rails as a MVC framework, so that comes out of the box with that. So in Ruby on Rails, what happens is every version is like a timestamp. So when you generate a migration, that will have a timestamp of that time. So even if multiple people are generating scripts, it will have a clash. Okay, and the system, the framework knows what was the last migration ran on a certain database, and it knows how to upgrade and all. And it comes with rollback scripts also. Okay. Next is automation. You need to have enough scripts so that especially automated tests to make sure that the schema changes is not affecting any other part, right? Especially when you are dropping a column, right? You want to make sure that no code uses that code, right? And also you need to prepare yourself for rollback, because anytime anything can go wrong, right? At any time, if you want to roll back to a specific version, you should have scripts for that too. Okay, so that is what the automation is about. And last bit is about strategy, right? This pattern, even though it is good, but it comes with its own pains. Like once you expand, you need to make sure that the contract happens. Otherwise, it will result in technical debt, right? You have both implementation and unnecessary triggers and other things, right? So as a team, what do you agree as a contract time, right? What is the transition period? And at what time you need to have what kind of migrations you need to apply this. Every time it doesn't make sense, because it has its own burden, right? So as a team, you have to make those decisions and stick to it, and then you have to continually improve those decisions. Look at what worked and what didn't, right? So that is a very key part, and that is where I think is where teams struggle also, right? Maintaining that strategy, updating that strategy accordingly. Okay, and when I give this talk, few of the time I hear, okay, it's a great idea, but it doesn't work here, or it doesn't work for me. This is the situation. Then I thought, okay, it's good to share some facts. Like I have been using this pattern for quite long, both branch by abstraction and expand contract pattern. I have seen that it works. Right, that is the reason I am sharing it in conferences. But I will also tell you like a few case studies that I've seen where they found it useful. One place is GitHub. If you look up for this particular title, you can see a few articles written on that. So this is not about databases, but almost all of you are familiar with GitHub, right? I think you use it. So GitHub, the key part of GitHub is when you submit a pull request, they give you the differences, and if there are any merge conflicts, it tells you that, right? So it has a merging algorithm, right? They found that it happened few years back. They found that algorithm was taking a long time, which is very, very critical for them. If that algorithm is taking longer, then users are going to go away, because the key part of them is giving that very quickly in an intuitive fashion. That is why GitHub was so successful, right? And they found that the library needs a change. And it's at that point of time itself, they had millions of users who was using it. So what they did was they took the branch by abstraction method. They had parallel implementation. They ran both the, they want to make sure that the new library they are using, how much more time I have? Okay. Okay. So what they want to make sure that the algorithm wise, the correctness of the merging should not change with the new library. Even though it is, even if it is performing better than the existing one, the algorithm has to be correct. So what they did was they had both of them running parallelly, made sure that the new algorithm is correct, and then they actually monitored that, and over I think 3 to 5 days is when they got rid of the old one. Okay, and you can read that, and then the stats that they've written about, okay, how they found certain issues while doing that, and they fixed it. Even without opening it to the end users, they found issues with that. And it happened because they are actually delivering multiple times a day, maybe 60 to 70 times a day into production, right? So things can go wrong. I've been keep on saying that. So okay, so the next, while it comes up, next example is from Facebook. Facebook extensively uses expand contract pattern for database changes. So they make sure that almost every change to the database goes it as parallel change, right? They have a strategy to contract because they have, so they don't release to the public all the time, right? They first release, they follow canary releasing. That is, they first release to the internal customers, the internal employees, then to a certain set of users. During that time, they know whether there is the database changes does it have any impact, negative impact. Okay, so they use it extensively, and then this blog post, I'll share this presentation after the talk, so you can look at this. The motto is move fast and break things. But even there, they have seen success with these kind of patterns. They are able to release safely, right? And last one is about the similar pattern can also be used for killing existing applications. Strangler application is if you have a monolithic application and you want to create small applications, or if you want to rewrite it, right? How do you do that in a continuous delivery fashion, right? So what you do is you create small application, or you rewrite it, and whatever you have rewritten, you route to the new implementation, and then kill the old one over a period of time, rather than going into as a team going into a room, rewrite the entire application and release it, right? So you can even continuously deliver you can continuously rewrite applications using this pattern. Okay, so this if you search for there is this person called Paul Hammond. I don't know how many of you have heard. He has written a lot of case studies where they've applied this pattern for rewriting applications. Okay, and you can look at branchbyabstraction.com. He talks extensively about this pattern. Okay, that's all. Just to summarize, things will always go wrong. So what you want to lower the risk of releases. And for that, the main thing is release in small batches, not big batches. That means never release in a big chunk. Continuously release. And this kind of patterns help you to do that. Right? For a period, you may have duplicate code, but that's worth it. Right? And these are the references. You can look out for refactoring databases for further about how can you apply refactoring into database and different kinds of refactoring that you can apply. Okay, highly recommend it. And that's it. If we have time for questions.
Yeah, do you have any questions?
Either it's all clear or everything is over the head.
Anyway, thank you for the session.
I'll be here, you can catch hold of me. Okay.
Small token from AgilityToday.